Hello, guys. So today we'll be looking at system reliability in operations management. So when we say system reliability, we are basically looking at the probability that a machine will function properly for a specified period of time. Okay. So a machine will be reliable when it's 99% efficient. Okay, like it's most efficient when it's 99, when the reliability is 99. Okay, we wouldn't accept anything below 70%. So let's say above 70% is reliable, but most efficient, you can rely on a machine when it's at least from 90, let's say 80, above 70, right? But I would, per preference, I would say that if it's above 80, 99, yeah, then it's most reliable. Do you get it? Uh-huh. So here we are not coming to talk about reliability and what it is and all that. We are coming to look about at how we can calculate reliability in a system, especially the components in a system, how reliable they are. Okay. So that is what we are going to look at today. So mostly the um, formula for calculating system reliability. So reliability is then with a subscript X. So system reliability, okay, is mostly R subscript 1 times R subscript 2 times, sorry, times R subscript 3, and it continues like that. Okay. Now, I should point out certain things to you. To be able to calculate the reliability of the system, we should first of all understand the layout. Okay. So some components in the system may be in series. So let's take for example, um, we have 0.9. So this is a component. Okay. So I'll label it as R1. Then we have 0.8. This is R2 component. Then we have 0.99. Okay. So this is our system. This is the system that we have. Okay. So now look at the layout. So you see that we move from R1 to R2 to R3. So in this case, it's in a series form. Okay. Series basically means it's related. So from here, you go here, from here, you go here. So this is in a series form or is in a straight line form. In this case, calculating the reliability of the system is very easy. So in that case, you just go for this formula where you just put everything in. So the reliability of the system will be equal to R1, R2, R3. So R1 times this times that. So we are just going to put everything in there. So the component 1 is 0.90. You multiply that by component 2, which is 0.80. Then multiply that by component 3, which is 0.99. Just punch all of this in the calculator, okay, and you're going to get 0.7128. Then you multiply that by 100, okay, to get the percentage, which is 0.3 to 3 decimal place percent, okay. So is either you leave it in this form or this form, but most preferably you leave it in this form. So when you get here, you just have to multiply it by 100 to get the percentage format of this. Okay. So with a series system, this is how you calculate for your system reliability. Okay. At least it is 71%, 71.3% reliable. Okay. So which means at least it's good. Okay. And it will function for a specified time period. All right. Now, this is just the first layout. There are other layouts as well, but let's take it step by step. Okay. All right. So let me say this is one. So let's check another layout. What if the layout is like this? So this layout is called the Paro layout. The Paro layout. Okay. Now this layout came into being when let's start from here. You see this very system here. You move from one, you move from one to two, then two to three. Okay, so there's R3. You get it. All right. So in a situation where the R2 breaks down, so let me do like some small connection here. So in the system, when this component finish, it just move on to the next component. When this one finish, it move on to the next component. Now, in a situation where this component fails, it fail, okay, or it break down, it means there's going to be a backlog, which means that we have to fix this component before we can continue with our process or our function. Okay, so if it's a system, this has to be fixed before we can move on. And the same thing that applies here. So which means that if this component, which is 80% reliable, fails, okay, it means that we have to fix it before we can move on with our process. Okay. So that is where the redundancy came in. So the redundancy is trying to say, so okay, fine. Let's add another component, let's say over here. Okay. So that we can have from here to here to here. So if this system here fails, then the next component, which is the redundant component, can just continue. So we wouldn't have to wait for this one to be fixed before the process continue or before the system functions. Okay, which means that this serves as a backup. Do you get it? So we'll create another component, let's say at the top or down, so that when this R2 breaks down, it continues. So that is how come we came into this. Okay, we came to have this. So in this layout, you realize that we have the lower component to be 0.98, the upper component to be 0.99. Okay, so in the situation where the 0.98 fails, the system still functions because you have a redundant or a backup, okay, which is 0.9, which it will still function. Okay, so if it's moving this way, okay, and this one breaks down, it still functions. So basically, that is the whole idea. Do you get it? So in the Power format, okay, there are two approaches to solve this question. Unlike the series where you just have to multiply everything through, with the Power, there are two approaches. So I call them the failure method and the reliability method. Okay, so let me demonstrate them to you real quick. So let's try solving this, the reliability of this system. Okay. Okay, first we'll use the reliability format. So for the okay, so let me just divide this into two. Okay, because we are using two formats. Anyone works, okay, anyone works. So we are using the reliability format, okay. So with the reliability format, we are saying that to measure the system reliability, you have to use this formula where let's say R1 plus, you open a big bracket, R2 comes in, you open a smaller bracket, you less R1, okay, from it, then you close the bracket with a bigger bracket. So this is the format for the reliability for, sorry, the reliability format for calculating the redundant system. So let's put everything in and see how they match. Okay. All right. So with this, you can take any of the values in the component. Okay. So for me, I would like to start with the lower part. So in calculating this, I will say the reliability of the system equals 0.98 plus, I open a bigger bracket, I bring my 0.99. Okay. Then I open a smaller bracket, which means this one is multiplying. Okay. I open a smaller bracket, then I'll bring 1. Okay, less the 0.98 again, then bigger bracket. Now this small bracket here is just you multiplying the failure of R1. Okay, so you see this component and this component. Okay, we are just multiplying the failure of this component to that of this. Um, sorry, we are multiplying is the 98. Okay, so we are multiplying the failure of this to that of this. So that is it. So not to confuse you, this is this is a failure format. Failure, yeah, it's a failure format. So we are just multiplying the failure of this 0.98, which is this one, to this. Okay. Let's continue. I think you get the understanding. So we'll repeat this 0.98 plus. Then we open our big bracket. So this minus 1 minus 0.98 is going to give us what? 0.02, right? So we multiply this and we are going to get what? So basically, you can just punch everything into the calculator and it will give you the answer. But I'm doing it step by step so that you get the understanding, okay? So if you multiply this by this, you're going to get 98 plus 0.0198. Okay, so then we add this and this. Do you get it? So when you add, you're going to get 0.9998. Okay, or 99.98%. Okay, so which means that this is the system reliability of this component. Okay. All right, so this is the system reliability format. Now let's look at the failure format. So with the failure format, what we are going to do is that we use 1 to represent the whole component. So the whole component is 100%. We assume it is 100%. Then you less all the failures from each component from it. Do you get it? So you open a big bracket. The failure for this component, so small bracket 1 minus 0.99. You close bracket. That is going to multiply the failure of this. So it is 1 minus 0.98. Bracket close, bigger bracket. Do you get it? So now we just have to work everything out. So we repeat our 1 minus, then bigger bracket. This 0.99 from 1 is going to give us what? 0.01, right? So we multiply that by this 0.98 less 1 will give us what? 0.02. Okay. All right, so we continue. So 1. So 0.01 times 0.02 will give us what? It's going to give us 0.0002. Okay. So then with this, so this is 1. So we less this value from the 1. So when you less it, you are going to get 0.9998 or 99.98%. I didn't approximate this because it then becomes 100%. Okay. So I leave it like that. But then if it wouldn't run up to 100%, I'll just run it. Okay. So basically that is how it is. So these are the two ways for calculating a system in a parallel format or a redundant system. Did you get it? So you can either use this format or this format, depending on the one that is easier for you. Okay. And like I said, you see, I less this from this. Okay. It's the same thing over here. That was what I was trying to explain earlier. So you see this 1 minus 0 point. So it's a failure format here. This small failure, this one. So when you less this from 1, the remainder is a failure part. Okay. So what we are trying to say is that this is 98. 98. So meaning the system can function like 98%. So the remaining 2 that will add up to make 100, is the part that fails. So that is the failure aspect of this component. But then it can function 98% accurately. Okay. So that is what we do here. So we just use that part to calculate our system reliability. So it's either you use this format or this format. As simple as that. So now that we understand this small system here and also this small series system here. So this is a series system, this the redundant system. Now let's move on to a more complex question, okay, and see how we'll go about that. All right. So let me shift this. Okay, so let's find the system reliability of the figure on the screen. Okay. All right. So in that, you realize that, let me draw everything here. So let me quickly draw everything. Okay, so this is how the figure looks like. Okay. So to find the system reliability, this is very simple. Now, calculation of the system reliability in operations management is very simple. You just have to understand where to calculate your redundancy and when and where to calculate your system when it is in series. Okay. So now, if you look at the figure very well, you realize that this side of the system is in series. You also realize that this side is also in series, but then they are linked together. That makes them redundant. Okay. So I was saying that um, when they say parallel, the system is in parallel, meaning they are facing each other. Anything that is facing each other but not touching is parallel. Okay. So when lines are drawn like this, okay, this and this are parallel lines because at the end they are not touching each other. Do you get it? So whether it is straight like this or like that, they are in parallel. Okay. So that is how this also is. So this one is facing this is facing this is facing that. But basically you realize that they are all in series. Okay. So first, what you are going to do is you have to solve this section in the series format. Solve this section in a series format again. Then you use the answers for both, and you use the what's it called? Either the failure method or the reliability format to solve it in a redundancy form. Okay. So I think let's do it together to see what I'm trying to say. So first, let's label them. So I'll label this A, B, C. So component A, B, C, D, E, and F. Okay. So I'll find the system reliability of this one because this lane is S1. So the system reliability of this is going to be A times B times C. Do you get it? So that means that 0.99 times 0.98 times 0.90. Okay. So when you multiply all this together, you are going to get what? 0.87318. Do you get it? So when we multiply all this, we had this. So this has become one component now, or the reliability of this side. Okay. So uh, let me draw it as a component here. So 0.87318. It's too small, but I hope you can see. So it's just this that I've written here, okay? Then I'll also calculate for this in another series format, okay? So RS2 equals, which is what? D times E times F, okay? So it's going to be 0.99 times 0.98 times 0.90. Oh, is basically the same. Okay, which means that we are going to get what? Another 0.87318. Do you get it? Okay, so this becomes another component, which is 0.87318. All right, so what I mean is that when we found for the first series, okay, we had one component. So basically, we multiplied all of this to get one component. So let me draw it here. So when we multiply, we have 0.8731. Okay. Then we also multiply all of this to get another component, which is 0.87318. Okay. So now look at what we've gotten here. So we've gotten so it's like simplifying. So we try to simplify this whole component. And after simplifying, we've gotten just a small component to work on. So now that we've gotten this small component, then we can apply this rule. You see how we solve this rule. Either you use this or this to solve for this. Do you get it? So then it becomes simple. So we can use the failure format or the reliability format. Anyone can be used to solve. So let's just go ahead and solve this. So let me divide it. You just have to choose one, the one that is most comfortable for you. Okay. All right. So using the reliability format, so we are going to get the system reliability to be what? So we just bring in 0.87318 plus, we open a big bracket, we repeat the same 0.87318. Okay, open small bracket, 1 minus 0.87318, bracket close, bigger bracket. Okay, so you can just punch everything into the calculator to give you an answer. Okay, so let's not waste time with solving it one after the other. So just punch everything in. So when you punch everything in, you're going to get 0.9839166.876. Okay, or 98.4%. So like I said, when you get this, you can convert it to this percentage. Okay, you multiply by 100. So when I multiply this by 100, we had 98.4%, which is to one decimal place. You can choose to do it to decimal place. You are not wrong. Okay, but most important, write this first, then you choose how you are going to put it in percentage format. So let's use the failure format to see if we are going to get the same answer. So like I said, with the failure format, we assume this whole system to be one. Okay, one functional system. Then we open a big bracket. Then we less the failure for this component and this component. Okay, from one, and we'll multiply them. So it's going to be small bracket 1 minus 0.87318. Okay, you close bracket, you open another bracket because they are multiplying. Okay, 1 minus 0.87318, bracket close, big bracket. You get it? All right, so then we continue. We bring our 1 here, then we less this from each other. Do you get it? So we first less this one. So big brackets. When you less this, you are going to get 0.12682. Okay, which is multiplying another 0.12682. Do you get it? So big bracket. So we multiply these two together. So 1. When you multiply these two together, you're supposed to get 0.016083. Okay. 1, 2, 4. All right, so this is what we are going to get, this whole number. You see, I wrote everything. I didn't approximate any. I just wrote everything there because we need it to find the final answer. Okay, so it is the out of the final answer that you can approximate. So don't approximate on the way, please, or you're going to get it wrong. So you less this whole value from 1, and you're going to get 0.983916687. Okay, or you're going to get 98.4% to 1 decimal place. So you see, we had this and we had the same thing here. So you choose the one that is most comfortable to you. So the whole idea is that when you get anything, any complex system, you just have to simplify it by putting it into this format. Then you use either the reliability format or the failure format to solve for it. Either way, you are going to get the answer. Okay, so that is that for this question. Okay, all right, let's try one more question, then I think we'll be good to go. Okay, so let's solve for the system reliability of the figure shown on the screen. So let me draw it for clarity's sake. Okay, all right, so quickly. Okay, so looking at this system, you realize that it's very complex. Okay, it's a complex system. Now, one thing I believe in is trying to simplify everything so that you can solve it. Okay, so first thing is, let's try and identify the series portion in it. So realize that there's a box here. Okay, so which means we'll solve what is here first before we come here. Okay, so first you realize that this one is in series. Okay, then these ones are parallel. Do you get it? So we have to solve this one first before we come here. So if you see similar boxes where there's some in a parallel, then some is outside, kindly solve those in this loop first before you come here. Don't go and add this to this. It will complicate everything. Okay, and probably might end up getting it wrong. So here in this system, this is what we are going to do. It's already labeled. This is R1, R2, R3, R4, and this is R5. Okay, so first thing we'll do is we'll multiply these two because they are in the series. We are doing the one in the box first. So we multiply these two. Okay, so we'll say system reliability for R2 and R1 will be like this. So it's going to be 0.95 times 0.95. Now here the values are the same, okay, but probably in your question you can get different values, but it's the same approach, same procedure, okay, so you don't have to worry. All right, so when you multiply these two, you are going to get what? 0.9025. Okay, so this answer, okay, becomes a combination of this. So we are going to get R2, R3. Okay, it said RS equals this. So the answer is your R2, R3 put together. Do you get it? So that is your system reliability for this. Do you get it? All right. So now that we've gotten R2 and R3 put together, these two put together, now this is how our system looks like. So it's going to be like the 0.95, then 0.9025, and 0.95. So this, okay. So now from this complex process, when we multiply these two, okay, this is what we've got. Okay, so now our system has become something like this. Okay, we are trying to simplify it. When you know it, you can just solve it straight ahead. Just when you see this, just solve it. Okay, but I'm trying to simplify it so that you know how we got things. Okay. All right. So now this has become the parallel, the actual parallel. Now, when things are in parallel, you know there are two ways to solve it: the failure format and the reliability format. Okay, so let's try and solve this using the failure or reliability format before we come in. So when we use that, we will get an answer, one answer, then the answer we use it to multiply this to get our overall system reliability. You get it? All right, so let's move. So we start with the failure format, okay? So with the failure format, I told you that the system, sorry, the system reliability is going to be what, 1. So we assume that all this is 1, or all this here is just 1. Okay, it's 100%. So we less big bracket. So big bracket. Then you less the failure of each. Okay, from it. So let's first label them first. So we are going to get small bracket 1 minus R1 bracket close. Then you open another bracket 1 minus R2 R3. Okay. Then you open another bracket 1 minus R4. Okay. Okay. Because now we have, this is R1, this is R2 and R3 put together, and this is R4. Do you get it? And here is still R5. So here we'll not touch it. We will solve this one first before we come here. All right. So we move 1 minus. So let's put actual figures in. So 1 minus open bracket 1 minus 0.95. Open another bracket 1 minus 0.9025. Okay. Then open another bracket 1 minus 0.95. Okay, then big bracket. I hope we are making progress. So this is what we've put here. Then equals 1. You less. So then we have to find for each of this. Do you get it? So here is going to be 0.05, which is multiplying. Here is going to be 0.0975. Then the last one is going to be 0.05. So then we multiply all of them together. and we are going to get 0.00024 375. Okay, so then we less this from here, and we are going to get what? 0.999756 2 5. Yeah. So this is for this component. Okay. You realize that it's this one that we've broken it down to this. Okay. So it's for this whole component. Now we've gotten the reliability for this whole component. So then we multiply it by this. Okay. So now this has become one component, which is this here. Okay. All of this has become one component. Okay. So we then multiply it by the 0.95. Okay, so this I'll put it as 0.999755625. Okay, so now you see that this has become in a series. Okay, so you use a series format to solve for this. Okay, so you see how I broke it down from here to this, then from this to this, where it's now in series. So we just use a series to solve it. So with a series, all you have to do is just what you multiply. And so it's going to be your RS, which is your system reliability. So this becomes the R1, R2, R3, R4. Remember that is R1, R2, R3, R4 all put together to get this, and this is what R5. You get it? So if you understand, you don't need to do this. You just have to just calculate straight ahead. Okay. All right. So we continue. So now all this has become this, which is this. So to find our system reliability, we just have to multiply 0.999755625 by 0.95. Okay, so the answer that we are going to get is what? 0.9497684375, or 94.98%. So like I said, you see I wrote everything. When I multiply, I wrote everything before I sent it to decimal. So when you multiply this by 100, you are going to get it into this form. You get it? So you can further, instead of doing or, you can add, multiply by 100, then you write this down here. It's still acceptable, okay? All right, so that is how. So this is for the failure format. So the failure format, our system reliability is going to be 94.98%. Do you get it? All right, so let's use the other format, the reliability format, to see whether we'll arrive at 94.98%. Okay, I think that will be the last one, and I presume you understand reliability. All right. So with the reliability format, our system reliability will be written as where is it at? R1 plus, you open big bracket, R2, R3, open a small bracket, 1 minus R1, bracket close, big bracket. Okay. So we are continuing from this session. Okay. Since we simplified this into this, okay, we are continuing from this session. Okay. So this is where you see it's parallel. So this is where I said you use the failure format or use the reliability format. And we've already used the failure format to solve for this. So we are using the reliability format. So with the labeling, the reason why I wrote R2, R3 here is because we calculated for them here. You see this R2, R3. We just multiply these two, okay, to get to this. So this R2, R3, and that is what I've written here. Okay, so with the reliability format, what we are going to do is we are going to find this and this. Okay, then the answer that we get for this and this, we use it to find this and this. Okay, then the total answer we multiply it by this. Okay, so this is how you go about it. Um, so let's put in the figures. Okay, the values. So it's going to be R1 is 0.95 plus, you open bracket, 0.9025, small bracket 1 minus 0.95. So 0.95 plus, open bracket, 0.9025. Okay, is multiplying 0.05. Okay, all right, so 0.95 plus, so you multiply this and this, you are going to get 0.045125. Then you add this and this, you are going to get 0.995 125. Okay, so this will become your system reliability. Your system reliability. So the answer you are getting here is for R1, R2, and R3. Do you get it? So the answer that you've gotten here is for R1, R2, and R3. So now that we've gotten this, okay, so our components have been shortened to this. Is how our component has become now 0.995125, then 0.95. So this is how our component has become now. This is R5. So this is R1, R2, R3, and this is R4. Okay, I hope you can see that. Yeah, so all from, we deduce it from using this and this. Okay, we deduce all from here. Okay, so using this and this, we now have this. Okay, so we just have to use the same reliability format to find this and this. Then finally, we will use a series to find this. Okay, all right, so let's continue. So let's find for this and this. So we say our system reliability will be equal to, so I choose this one first, 0.95 plus, you open big bracket, you put in this value 0.995125. Okay, open small bracket, 1 minus 0.95, big bracket. Okay, so equals 0.95 plus big bracket 0.995125. Okay, you less this one, you're going to get what? 0.05. So you multiply this, you're going to get 0.95 plus, so the answer for this will be what? 0.04975625. Remember, I'm writing everything, I'm not approximating. It's only the final answer that you can approximate. So then we add this to this. Okay, so we are going to get 0.999752625. Okay, so now this is R4, this R1, 2, and 3. Okay, so after putting them together, we are going to have R1, R2, R3, and R4. Do you get it? So this has become one component now. Okay, which is like this, 0.999752625. So this is R5, this is R1, 2, 3, 4, 4. Okay, so this is R1, 2, 3, 4, and this and 5. So we are just using the series format to complete this, and we are done. So this is the answer for R1, 2, 3, and 4. So all that we are going to do is to find the total system reliability is going to be 0.99975 times uh, R5, which is 0.95. Then your answer is going to be what? 0.9497684 375, or you multiply that by 100, multiply this by 100, and you're going to get 94.98%. Do you get it? So you realize that this answer that we had is the same thing that we had here. Do you get it? So you choose the format that is most easy for you. Okay, the one that is easy for you. You stick to one. Don't use both. Okay, because in exam setting, you won't get time to be doing all that. So you stick to the one that is easy for you. Okay, so if it is the failure method that is easy for you, stick to it. Then use that one to solve. If it is the reliability format that is good for you, stick to it. Use that one to solve, and you'll be good. Okay, so always make sure you simplify complex systems, okay, into smaller modes, then you solve them. You get it? So I think that's all for reliability, and you'll be able to solve most questions on your own from here. All right. So see you in the next video where we solve for project management, activity on Arrow, and activity on Node. Thank you. See you.